there, my fellow curious minds, and welcome back to Tech Advantage, the podcast where we talk about technology, business, and personal growth. I'm your host, Tondow Abraham, co founder and head of technologies at Bluemind. And today on this podcast, we're going to be talking about artificial intelligence 101. So, as a way of basic introduction, artificial intelligence could be machines or softwares designed to perform tasks that normally require human intelligence. If you have been around tech long enough, you've probably noticed that AI is everywhere right now. Chatbots, image generators, recommendation systems, you name it, everyone is building AI. But here's the truth most people don't talk about. Calling an AI API is not building an AI system. Behind every serious AI product is a carefully engineered pipeline comprising of data, models, infrastructure, mathematics, and constant monitoring. So, in today's episode, we're going very technical. I want to break down how modern AI systems are actually built from raw data all the way to production deployment. And if you're a developer, an engineer, or a founder building AI powered products, this episode is for you. So let's get into it. Here's a big picture of what an AI system really is. To all of my software engineering brothers, there's a category of phases that are involved in engineering a software. It begins from the analysis phase all the way to the testing and deployment. So, in developing AI systems, we have something very similar. At a high level, a modern AI system has 6 layers: data, model architecture, training, evaluation, deployment, then monitoring and scaling. Most people only see the modeling. Engineers worry about all 6 phases, and everything starts with data. The real foundation of AI is data. Having accurate data is going to determine how accurate your AI system would be. And a hard truth is failures of AI system mostly is as a result of data failures, not model failures. Data comes in different form. We have structured data, which could be arranged in an adequate format, such as tables, numberings, could also be transaction. And we have unstructured data, which comprise of text, images, audios, videos, and so on. So before training even begins, data must be cleaned, duplicated, normalized, and properly labeled. The essence of all of this is to take out errors that could exist in the data. This process often takes more time than modeling training itself. And a critical step here is splitting the data. After you've been able to clean up your data, normalize it, and label it properly, you need to split it up into sets. We could have a set of data meant for training the model. We would have a set of data for validating the model and also for testing. If you leak information from one into another, your model will look good in development but fail in production. So you need to have this data isolated off of each other so that they are discrete. At this phase, a lot of AI systems don't make it through as a result of the accuracy that is required for such a model to be trained. So let's talk about models now. An AI model is not intelligent. It doesn't understand. It only learns statistical patterns from the data. If it reads through the data and sees a certain pattern of movement across the data, it learns and uses these patterns to make a decision for the validating and testing data. Today, most teams don't train models from scratch. Instead, they use pre-trained models, foundation models, or large language models, LLMs, and then fine-tune them for specific tasks. This is cheaper, faster, and more realistic, rather than having to design a model all the way from scratch. We can then further utilize already existing models and niche them to specific tasks. This is majorly feasible in regions like Africa, where computing power is very expensive and unaffordable, to be honest. Now, I want to talk about something that is slightly technical and mathematical. At the core of training an AI model is optimization. The model tries to minimize the loss function. A very simple description would be the loss is equal to how wrong the model is. Now, for example, if we have the summation for all of the mean squared calculated, where we have true values and model prediction values, training is the process of adjusting the model parameters to minimize the loss. This is done using a gradient descent. Conceptually, we compute the gradients of the loss, we move parameters in the opposite direction, repeat for thousands and millions of times, and all of this is made possible as a result of GPUs. So this is where GPUs really matter, because these calculations are massively parallel. You don't need to memorize the math to build systems. All you need to do is understand that AI is mathematical optimization and not magic. And this majorly changes how you engineer your products. Now let's talk about training the model. This is a subset of AI where systems learn from data instead of fixed rules. It also can be referred to as machine learning itself. In training the model, computing costs explodes here, and ultimately, infrastructure matters. Some key concepts are epochs, which is like a time frame for a specific training to occur. We also have batch size, which could be the number of data samples processed in one go before the model is then updated. I mean, its parameters. Another key concept is learning rate. Now, during training, this could be referred to as a crucial hyperparameter in machine learning that controls the step size for updating the model weight. And then we have distributed training. Here, it splits the large machine learning task across multiple processors to enable delivery in a shorter time. Training models require GPUs, TPUs, high memory, and a very stable pipeline. And this is why many African startups fine-tune smaller models or manage cloud AI services, because training is not just technical, it's economical. Now let's talk about deployments of AI projects from notebooks to real users. And by notebooks, I mean Jupyter. So those of you that are very familiar with Python, you'd understand what this means. Here, many AI projects fail. A trained model in Jupyter Notebook is not a product. In production, models are wrapped as API, deployed in containers, scaled to handle traffic, and ultimately optimized for latency. And a very important distinction is that training happens rarely, but inference constantly happens. So you need to understand the difference in the computing power for inferences as well as training. A slow inference pipeline can kill user experience and increase costs. This is where cloud architecture, caching, and load balancing matters. Now we move to monitoring. AI does not stay good forever. One of the most overlooked truths is AI decays over time. And why? This is as a result of the changes that happen in user behavior, data distribution, and real-world pattern evolution. So this is called data drift or model drift. Production AI system must monitor accuracy, latency, costs, and input distribution. Now, before we further, I'll just reiterate all that I've discussed so far. We spoke about the six major layers that are involved in AI system. We spoke about data. This has been regarded as the major foundation for AI. And when we have our data, we first of all clean it up, ensure it's error-free, and then we split the data to three sets. Now, after splitting the data, we ensure some portion are meant for training, some for validation, and some for test. And then we spoke about models, which comprise of mathematical computations that enable decisions by the system. After that, we discussed training, which can also be regarded as the machine learning itself. Here, the model is fed with a portion of the data meant for this purpose to enable the model map out some statistical patterns in the data. Then we move to the evaluation phase, which is making adequate decisions that regard the infrastructure to be used to enable computation costs and GPU's economics. Then we also moved to the deployment, where we talked about converting all of our notebooks to real products. And then we moved to monitoring, which ensures that the AI system is stayed up to date to reduce any form of latency, ensure accuracy at a best possible cost. So now let's talk about the future of AI and where all this is going from here. Best believe that we're moving towards some really advancement in the aspect of artificial intelligence. We're going to be having smaller yet efficient models. We're going to be having more domain specific AI, like AI needs to operating systems, banking sectors, and so on. We're also going to be having some edge and on device inferences and tighter integrations with cloud systems. The advantage will belong to engineers who understand systems and not just models. Now, if you're to take one thing from this episode, let it be this: AI is not magical or some gibberish that brings out information from nowhere. It's mathematics, data, infrastructure, and discipline that happens as a result of efforts to build a system that communicates with all of its components. When you understand how AI systems are built end to end, you stop being just a user of technology. You ultimately become a builder. And if this episode resonates with you, do listen again because there's a lot of good information packed on here. Share this podcast to a friend and also leave us a 5-star rating on wherever you're listening from. Thank you for following Tech Advantage thus far. And remember, technology is your advantage.